Hello, here we are in 4.2, trig functions, the unit circle. Alrighty, so let's begin with this. Our learning objectives for this section is going to be using a unit circle to define trig functions of real numbers. We're going to recognize the domain and the range of the sine and cosine functions. We're going to find the exact values of the trig functions at pi over 4. We're going to use even and odd trig functions. We're going to recognize and use fundamental identities. We're going to use periodic properties. And finally, we're going to be evaluating trig functions with a calculator. So that last one's a pretty easy one. But there's about 7 objectives that we need to follow through here. But let me explain to you basically what trig functions are for those who have never even heard of trig functions. There are going to be 6 of them, okay? And the trig functions are, all they are is ratios. So if you're taking a trig function, no matter which one you're doing, of an angle, that angle is going to indicate a different ratio between a y-coordinate and the x-coordinate, or an x-coordinate or the y-coordinate, or a y-coordinate with the radius of the circle, or the x-coordinate with the radius. So there's 6 ratios there. Okay, so let's begin. Look at the unit circle. Unit circle is of radius 1 with the center at the origin of a rectangular coordinate system. The equation of the circle is x squared plus y squared equals r squared. So they took an arbitrary point on the circle, and we call that point xy, the xy coordinate. Okay, the radius in here in this case is t, and the arc length, I believe they're using it as s, okay? But so if you notice, the point on the x-axis is 1, 0. If you look on the other side, it's negative 1, 0. But the equation of that circle is x squared plus y squared equals 1, okay? So in a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. Both are given the same real number t. So here are the 6 trig functions. We have a sine, which is abbreviated sin. We have a cosine, which is abbreviated cos. We have the tangent, which is abbreviated tan. Cosecant, which is abbreviated csc. Secant, which is abbreviated sec. And then there's the cotangent, which is abbreviated cot. So the definitions of the trig function. So look at the unit circle to the right. I kind of just brought that back over here. If t is a real number and pxy is a point on the unit circle, so that's where the terminal side is going to land at x to y coordinate, and then that corresponds to angle t, then the sine of t is the y coordinate. Now you're like, well, I thought it was supposed to be a ratio. It is a ratio. It's comparing the ratio of the y-coordinate to the radius. Well, the radius is 1. So it's going to be y over 1. So the sine of t is a ratio that compares y to 1, which is just y. Now the cosine of t is the x-coordinate of that unit circle. So it would be x over 1. Y is because it's the ratio of the x-coordinate to the radius of the circle. Again, the radius is 1. Now, the tangent of t is the y-coordinate over the x-coordinate. It's a ratio that compares the y, the ordinate, to the x, which is the abscissa, the y over the x. Now, the remaining 3 are just the reciprocals of those 3. The cosecant t is 1 over y, where y is the y-coordinate of that unit circles where the terminal side lands. Secant is 1 over x, and the cotangent is x over y. And if you notice, there's a little restrictions there that says y not equal to 0. Well, the reason y can't be 0 on the cosecant is because you cannot divide by 0. So anytime that y-coordinate ends up being 0, then the cosecant would be undefined. Same thing with the secant of t. Secant of t is not defined when the x-coordinate equals 0. And the cotangent of t is not defined when the y-coordinate equals 0. So whenever the denominator is equal to 0, then it will not be defined. Okay? So, all right, so let's move on. So let's look at example 1. So we're going to find the values of the trig functions. So we're going to use the figure to the right here to find the values of the trig functions at t. Now if you look at t, we have an ordered pair where that radius hits, and it's going to be the square root of 3 over 2, comma 1/2. So square root of 3 over 2, comma 1/2. Now if you notice, if you take the square root of 3 over 2 squared plus 1/2 squared, it will equal 1. Because the square root of 3 over 2 squared is 3/4. 1/2 squared is 1/4. 3/4 plus 1/4 is indeed 1. So x squared plus y squared equals 1. So that point is indeed on the unit circle. So the sine of that angle t, whatever that angle t is the y-coordinate. And if you look at the graph, the y-coordinate is 1/2. The cosine of t, which is the x-coordinate, is the square root of 3 over 2. The tangent of t is the y-coordinate divided by the x-coordinate. Well, the y-coordinate is 1/2. The x-coordinate is the square root of 3 over 2. If you invert and multiply, that gives you 1 divided by the square root of 3. And that can be, this next part is just a formatting thing. We don't like having radicals in the bottom, so this is what we call rationalizing the denominator. So we multiply the top and the bottom by root 3. So you get the square root of 3 over the square root of 9, and the square root of 9 is 3. So you get square root of 3 over 3. Now the remaining 3 are just reciprocals of the first 3. The cosecant of t is the 1 over y, which is going to be the 1 over the sine function. And so it's going to be 1 over 1/2, which is 2, if you invert and multiply. The secant of t is the 1 over the x-coordinate, so it's going to be 1 over cosine, because remember the x-coordinate is cosine. So then it gives you 2 divided by the square root of 3 when you invert and multiply. Again, rationalizing the denominator ends up with giving us 2 root 3 over 3. And then finally, the cotangent of t is x divided by y, which is the x-coordinate divided by the y-coordinate. So it'd be the square root of 3 over 2 divided by 1/2. If you invert and multiply, you get root 3. Okay? So if you notice, there are 3 things going on here. It's the x-coordinate, the y-coordinate, and the radius. Well, I don't know if you noticed that, but if you have 3 things and you're trying to find ratios among those 3, there's 6 possibilities. So you have an x-coordinate, a y-coordinate, and the radius. Well, you can divide the y-coordinate by the radius, or you can divide the radius by the y-coordinate. You can divide the x-coordinate by the radius, and you can divide the radius by the x-coordinate. You can divide the y-coordinate by the x-coordinate, or you can divide the x-coordinate by the y-coordinate. That's 6 ratios, 6 trig functions. So it's not a coincidence that there's 6 trig functions, because there are 6 such ratios. Okay, so it's just a matter of fact that they come in pairs, and they're pairs of reciprocal functions. The sine and the cosecant are reciprocals. The cosine and the secant functions are reciprocals, and the tangent, which is y over x, is the reciprocal of cotangent, which is x over y. So, all right, so that's how you find the trig functions of a point on the unit circle. Now, the domain and the range of the sine and cosine functions. Well, the domain of the sine function and the cosine function is all real numbers. The range of these functions are 1 to -1, and the set of all real numbers from -1 to 1 inclusive. Now, let me explain to you why it is what it is by going back to the original picture here. If you look at that unit circle, so if you remember, the sine of t is the y-coordinate, right? So if the sine of t is the y-coordinate, well, it's always going to be defined, because no matter what the angle is going to be between 0 to 360 degrees or whatever, it will always be defined. So that's why it's always all real numbers. But I want you to notice, what is the smallest y value that I could have on that unit circle? -1. And what's the largest y value that I could have on that circle? +1. So let's go back. And notice it says the range is from -1 to 1, which is all the numbers between those. Now, if you look at the cosine function is the x-coordinate. Well, the x-coordinate is always going to be, the cosine of t is always going to be defined because x will always be whatever it is. But what is the range? Well, the range can go from -1 to 1 because the x's are going to go from the left side to the right side of that unit circle. So from -1 to 1. Okay, now let's go down a little bit farther. So exact values of the trig functions at t equals pi over 4. So trig functions at pi over 4 occur frequently. We use the unit circle to find the values of the trig functions at pi over 4. So we see that the point AB lies on the line y equals x, thus they're equal, so A equals B. So x squared plus y squared equals 1. This is the equation of the unit circle. So therefore, a squared plus b squared equals 1 because that's the point that I'm referring to, but they're equal. So I get a squared plus a squared because a equals b equals 1. Now we try to solve for a. So 2a squared equals 1 because a squared plus a squared is 2a squared. Then a squared is 1/2 divided by 2. And so a is equals to the square root of 1/2. And because a is greater than 1, it only takes the positive aspect of it. So technically it's plus or minus. So therefore, it's going to be actually plus or minus, just plus or minus, but it's just going to be plus the square root of 2 over 2 if you rationalize it. So the cosecant of pi over 4, you remember now you got the square root of 2 over 2, comma, square root of 2 over 2. So what is the cosecant of pi over 4? Well, it's 1 over the y-coordinate. Well, the y-coordinate is now square root of 2 over 2. So you invert and multiply, and it gives you radical 2. So the cosecant of pi over 4 is radical 2. Now the secant of pi over 4. Well, secant of pi over 4 is the 1 over the x-coordinate. And if you notice, it's exactly the same thing. Okay? And then the cotangent of pi over 4 is the x-coordinate over the y-coordinate. Well, the x-coordinate and the y-coordinate are the same, both radical 2 over 2. So when you divide two numbers that are the same, you get 1. So the values, the ratios at those particular angles are those three numbers respectively. Cosecant of pi over 4 is radical 2. Secant of pi over 4 is radical 2. Cotangent of pi over 4 is equal to 1. And you might ask, well, what about the sine, the cosine, and the tangent? Well, if you remember, the sine of pi over 4 is just the y-coordinate. So it would be just square root of 2 over 2. Cosine of pi over 4 is also the x-coordinate, which is also square root of 2 over 2. And the tangent of pi over 4 is the y-coordinate over the x-coordinate, so that equals 1 as well. So, okay. So, there it is. So, here's the trig functions at pi over 4. So, the sine of pi over 4 is the square root of 2 over 2. This is a little summary. Cosine of pi over 4 is the square root of 2 over 2. The tangent of pi over 4 is 1. Now, taking those respective reciprocals, because cosecant is 1 over sine, 1 over square root of 2 over 2 happens to be the root 2. And so we did those on a previous slide. All right, now another topic. Even and odd trig functions. The cosine and secant functions are even. So in other words, the cosine of negative t is equals to the cosine of t, and the secant of negative t is equals to the secant of t. Now you might want to know, well, why is that true? Well, if you remember, t and negative t are just opposite directions, okay, on the xy axis. So t would have like a coordinate of xy, and the negative t would have a coordinate x comma negative y, because you're going in the other direction. But they both have the same x coordinate, and cosine is the x coordinate, remember? So they would both be the same value. So that's why cosine of negative t and cosine of positive t are the same thing. Okay? And the secant is the same thing just because of the reciprocal aspect of it. Now the sine, the cosine, the tangent, and the cotangent are odd functions. So what that means is these things. Sine of negative t is negative sine of t. Tangent of negative t is negative tangent of t. Cosecant of negative t is negative cosecant of t. Cotangent of negative t is negative cotangent of t. Now you might want to, well, why is this? Well, you remember sine. Let's start about the sine. Now sine of t and sine of negative t. Remember the sine is the y coordinate, and if you go t, it's got a positive coordinate, and negative t would have a negative y coordinate if you go the other direction. So they're opposites of each other. And if you remember tangent is y over x, the y coordinate over the x coordinate. And so remember the x's are the same, but the y coordinates are opposites. So that's why if you take the tangent of negative t, is the same thing as the opposite of tangent positive t. They're opposites of each other. And so since those two are a fact, the reciprocals are also fact. So that's why cosecant of negative t is negative cosecant of t. So this is one of those things that you don't have to really know why they're true. I'm just trying to explain to you why they're true. But these are the things that you just kind of know, and you just memorize these items. So this is when you go through these notes, when you're looking at my videos, you pause it ever so often, and then you write these things down, and that way you'll have them in your notes. So this is just one of those items that's kind of like a definition. You just got to know it. All right, example 3. Using the even and odd functions to find values of the trig functions. Okay, so we're going to find the value of each trig function. So we're going to begin with secant of negative pi over 4. Now remember, secant and cosine are the even functions. So secant of negative pi over 4 is the same thing as secant of pi over 4. And if you remember from a previous slide, secant of pi over 4 was radical 2. So, and then the sine of negative pi over 4 is the opposite, because it's an odd function, of sine of pi over 4. And that's going to be negative square root of 2 over 2. You're like, why is that? Because, well, sine of pi over 4, if you recall, is root 2 over 2. That was in our little table on a couple of slides past. And the negative just stays attached. Okay, so here are all the fundamental identities. We begin with the reciprocal. Now this is just a summary of all the identities that we have discussed up to this point. So the reciprocal identities, sine of t is 1 over cosecant of t, and cosecant of t is 1 over sine of t. So if one's the reciprocal of the other is reciprocal of the first. Cosine of t is 1 over secant of t, and secant of t is 1 over cosine of t. Again, one's reciprocal of the first, second is reciprocal of the first. So they just flip. Tangent of t is 1 over cotangent, and cotangent is 1 over the tangent. So those are the 6 reciprocal identities. The quotient identities is the tangent of t is a sine over cosine. And you're like, well, we didn't talk about that one. Well, I kind of did, because if you remember, the tangent was the y coordinate over the x coordinate, correct? But which trig function was the y coordinate? Sine. Which was the x coordinate? That was the cosine. So tangent of t is the y coordinate over the x coordinate, and y is sine, and x is cosine. So therefore, tangent of t is the sine over the cosine. And I think you could probably figure out why the next one is true. Cotangent of t is the x coordinate over the y coordinate, remember? So this one's the cosine or the sine, or you can also look at it another way. Tangent and cotangent are reciprocals. So if the tangent is sine function over the cosine function, then the cotangent would be cosine function over the sine function because of the reciprocal aspect of it. And then there's the Pythagorean identities, which sine squared plus cosine squared of t equals 1. Now you're like, well, why is that true? Well, if you remember, the unit circle is x squared plus y squared equals 1, correct? X squared plus y squared equals 1. Well, what's y? Y was the sine function. What's x? Oh, that's the cosine function. So if you replace the x squared in that with the cosine squared, because x and cosine are the same, then you'll have cosine squared replacing the x squared. What's y squared? Well, y squared is the same thing as sine squared, because y and sine are the same thing. So therefore, sine squared is the same thing as the y squared. So we get x squared plus y squared equals 1. We get sine squared plus cosine squared equals 1. So this is why we call the Pythagorean identity, because x squared plus y squared equals 1 is one of the Pythagorean identities. So Pythagorean function. So that's why this was true. Now the remaining two is just an observation of the first one. See what I mean? 1 plus tangent squared equals secant squared. If you take the sine squared plus cosine squared equals 1 and then divide everything by cosine squared, then you'll get sine squared over cosine squared, which is tangent squared. And then cosine squared over cosine squared, of course, is 1. And then if you divide cosine squared by 1 divided by cosine squared, you get secant squared. So if you take the first one, sine squared plus cosine equals 1, and divide through by cosine squared and simplify, you get the second one. And then on the third one, if you divide everything on the top one by sine squared, look what happens. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And then 1 divided by sine squared is cosecant squared. So again, I'm just trying to give you an idea of why these things are true. They're just not just something that are made up. But these are what we call identities. And an identity is basically something that is always true as long as they are defined. If they are true as long as they are defined. So in other words, if you have any angle and you have sine squared of pi over 3 plus cosine squared of pi over 3 and do the math, you'll get 1. If you have an angle of pi over 4 and have 1 plus cotangent squared of pi over 4, whatever that is will equal a cosecant squared of pi over 4. It's going to be the same value. So these are called identities. As long as they are defined, they are true. Now again, these are identities that you need to put down on your paper. Just these are the fundamental identities. These will not be given to you on a test. These you have to basically memorize. No ifs, ands, buts about it. These are the things that you have to memorize. Now I've made your life a little easier than my life was when I was a student. We had a lot more identities, and you will get more identities as well, but these are the only ones that I'm going to require you guys to memorize. These are the fundamental identities. When I was a student, we had to memorize these three groups here, the fundamental ones, the reciprocal, quotient, Pythagorean, and about 5 other groups that we had to memorize. So we'll talk about those other groups later as we progress through trigonometry. But these are the ones that you have to memorize. The other ones that we'll talk about, if we need them on exams, I will provide them on the test for you. Okay? All right, so example 4, using the quotient and reciprocal identities. So we're going to be given that the sine of t is 2/3 and the cosine of t is square root of 5 over 3. And we're going to find the value of each of the 4 remaining trig functions. Okay, so the tangent of t, remember, is going to be the sine of t over the cosine of t. That was our quotient identity. Now sine of t was given, 2/3. Cosine of t was given, square root of 5 over 3. And then it's just a matter of doing the math. So you invert and multiply, be 2/3 times 3 over square root of 5. The 3's cancel, leaving you with 2 over root 5. And then if you rationalize the denominator, you end up with 2 root 5 over 5. So that is your final answer for tangent of t. Now cosecant of t is 1 over the sine because that's one of my reciprocal ones. And sine of t was given to be 2/3. So it's 1 divided by 2/3 inverted and multiply. It's 3/2. So I've got 4. I was given 2. I found 2 more, so I got 2 more to go. Now secant of t is 1 over cosine. And cosine is square root of 5 over 3. That was given. Invert and multiply, rationalizing the denominator. You get 3 root 5 over 5. And then the last one, the cotangent of t, is 1 over the tangent. And 1 over tangent was the one that we found at first. That was 2 root 5 over 5, so you take the reciprocal of that one. And then therefore you rationalize the denominator, you ends up being square root of 5 over 2. Now you might ask, well, wait a minute. If tangent was sine over cosine, can you do it another way? Can you do cotangent by taking the cosine function divided by the sine function? And the answer is yes, you can. Okay, so sometimes when you're coming up with the value of a trig function, there's more than one way to accomplish it. Okay, this author decided to evaluate cotangent of t by taking 1 over the tangent of t. But I could have just as easily taken the cosine of t divided by the sine of t, and the answer would have been the same. So that's the beauty of this. So there's not always just one way to do some of these problems. All right. So example 5, using the Pythagorean identity. Okay, so we're given that the sine of t is 1/2, and we're given that t is between 0 and pi over 2. Now, before I read further, let me explain what that basically means. So we know that the angle is in the first quadrant. You're like, how do you know that? Well, it says t is between 0 and pi over 2. So pi over 2 is 9 degrees, recall, from 4.1. So you start at 0, and you go up to 9 degrees. Pi over 2 right there. So it's in that first quadrant. So 0 to pi over 2 is where your angle is at. That's important. That comes up later. So we want to find the value of the cosine of t. So the question is, if I'm given sine, now remember what sine is. Sine of t is the y-coordinate. Cosine of t is the x-coordinate. So basically is what they're basically saying is, I'm given the y-coordinate on the unit circle. I want to know what the x-coordinate is. So, all right, so we know that the sine squared of t plus the cosine squared of t equals 1 by the Pythagorean identity. So what they're going to do is they're going to put that 1/2 in for the sine of t. But you're like, wait, you can't do that because it's sine squared. I know. But if you have sine of t as 1/2, sine squared of t is like sine of t times sine of t. So that's going to be 1/2 times 1/2, which is 1/2 squared. So now you just got to go through the math to evaluate, see what cosine of t is. So these are next just algebraic steps. 1/2 squared is 1/4. Cosine squared of t stays put. 1 stays put. Then you're going to subtract 1/4 to isolate the cosine function. So cosine squared of t is 3/4. Why is that? Because 1 minus 1/4 is 3/4. So now we got to figure out what cosine of t is, but we're given cosine squared. So we take the square roots of both sides. This is kind of like when you had x squared equals 16 and those kind of problems in algebra, and you got to get the x by itself. You take the square root of both sides. Same thing. So if you have cosine squared of t equals 3/4, take the square root of both sides to get the cosine function by itself. So it's the same as the algebra relationship. So cosine of t is the square root of 3 over 4, and the square root of 3 is square root of 3, and the square root of 4 is 2. Now you might remember, like, well, wait a minute. When I had the x squared equals 16, and I took the square root of both sides, I remember I had to do something. Yeah, you had to add a plus or minus, didn't you? And you're like, why aren't you doing that here? Why isn't cosine of t equal plus or minus that number? Well, remember, cosine of t is the x-coordinate, right? Cosine of t is the x-coordinate. Where are you at? Where is the angle located? The angle is located between 0 to pi over 2, which is the first quadrant. So being in the first quadrant, cosine of t will be a positive because the x-coordinate in the first quadrant is positive. So that's why that very first part is there. Because if they didn't say that, if they didn't say t is between 0 to pi over 2, when you took the square root of both sides, it would have had to be plus or minus the square root of 3 over 2. But the reason that they didn't include the minus here is because we know it's not minus because we're in the first quadrant. Cosine is the x-coordinate, which makes it positive because you're in the first quadrant. So that's all that's about. Okay? Again, I'm hoping you're writing these things down. Okay? Don't just kind of follow me through and listen to me. Okay? it's a good idea to write these things down. You can't just write and just visualize and remember the visual. Okay, you got to actually do this yourself. If in nothing else, just kind of mimic what you're seeing me do. Okay? All right. So the definition of a periodic function. A function f is periodic if there exists a positive number p such that f of t plus p is f of t. Basically, this is what I call a cyclic. It cycles. Okay? So in other words, you have this f of t, okay, and it goes around and then it starts over again back to the same thing. Okay? So if you think about a unit circle, okay, when you get to 0 to 360 degrees, or 2 pi, remember 2 pi is 360 degrees, at 2 pi, everything starts over again, doesn't it? Because you're back to the beginning. Well, every 2 pi, it just starts over and over and over again. So if you look at this, for all t in the domain of f, the smallest possible number p for which f is periodic is called the period of f. So in other words, the point that it starts all over again, that's the period. So if you look at the sine function, the periodic properties of the sine and cosine functions, excuse me, the sine of t is plus 2 pi is equal to sine of t, and the cosine of t plus 2 pi is the cosine of t. Now if you remember, the sine of t plus 2 pi, the sine of t is the y-coordinate. Remember, the sine function is the y-coordinate. So it's going to have that same y-coordinate again when it goes back to 2 pi. Okay? And then the same thing with the cosine is the x-coordinate. It's going to go back to that same x-coordinate when you get to 2 pi. And the periodic properties of the tangent and cotangent is going to be tangent of t plus pi is equals to tangent of t, and the cotangent of t plus pi is the cotangent of t. So basically what they're saying here is the tangent and the cotangent functions, their period is just pi, not 2 pi. And you're like, why is it different? Well, it's different because of how they're defined. The tangent, remember, is the y-coordinate over the x-coordinate, and the cotangent is the x-coordinate over the y-coordinate. So remember, they place the same values. Or if you remember, if you have a point in the first quadrant, for example, you have the y-coordinate divided by the x-coordinate, right? And they're both positive. But they're going to give you that same value again when it gets to the third quadrant. Why? Because there's a negative y over a negative x. But they cancel. The negatives cancel, giving you the same ratio, y over x. So that's why. It only, every 180 degrees, it starts over again. So, but again, I mean, it's not really totally necessary to know why these things are true in this course. It makes it easier to understand, but it's the bottom line is you've got to know how to use the identities, because these are really definitely just kind of like identities anyway. But you just got to remember that the sine and cosine are periodic, which means it starts all over again every 360 degrees, or 2 pi radians. And the tangent and the cotangent start all over again every 180 degrees, or pi radians. All right, so let's use these periodic properties. So we're going to evaluate cotangent of 5 pi over 4. Now, if you remember, cotangent of 5 pi over 4 is the same thing as pi plus pi over 4. But you remember, cotangent's period is just pi. So cotangent of pi over 4 plus pi is the same thing as the cotangent of pi over 4. And the cotangent of pi over 4, remember by the previous slide that we had, is 1. And then the cosine of negative 9 pi over 4, well, negative 9 pi, or cosine of negative 9 pi over 4 is equal to cosine of 9 pi over 4. Do you remember why that's true? Yeah, if you said cosine was an even function, remember cosine of negative t and cosine of positive t are the same thing. So there's a lot to remember here. This is not that easy to remember all this stuff. So cosine of negative t and cosine of positive t are the same thing. So cosine of 9 pi over 4. But 9 pi over 4 is the same thing as pi over 4 plus 2 pi. And then since cosine is 2 pi, we can just drop that off, give me the cosine of just pi over 4, which is the square root of 2 over 2. Okay? All right, repetitive behavior of sine, cosine, and tangent functions. So for any value, for any integer in real number t, sine of t plus 2 pi n is the sine of t. Cosine of t plus 2 pi n is the cosine of t. And the tangent of t plus 2 pi n is tangent of t. Now they're getting a little bit more formal on you. Okay, you're like, what are these n's about? Well, what they're basically saying is if you have a certain angle for the sine and you go 2 pi, you get back to the same place, like we just said. Well, if you go 4 pi or 6 pi or 8 pi, it's all going to be the same. So what the previous slide was basically saying is just one revolution. Well, it would also apply for multiple revolutions. So 2 pi n is talking about multiple revolutions. On the cosine of t plus 2 pi n is the cosine of t, so multiple revolutions. So for example, if you have an angle that is like, I don't know, 17 pi over 4. Well, that's multiple revolutions around it. And then, so what you would have to do is figure out how many multiple revolutions that you have. And I believe that's 2 revolutions at least, and then some. So that's what it is. So, and then the tangent of pi, t plus pi n is multiple of half of a revolutions. So pi n is a half of a, pi is a half of a revolution. And then basically pi times 2 would be 2 halves, make the whole revolution, or 3n, which is basically 3 halves of a revolution. So it's half all the way back around and then one more half. So 3 pi is that. So basically what it says is if you have the tangent of, let's say, pi over 6 plus 3 pi, then it's the same thing as the tangent of pi over 6. So that's what it says. Okay, finally, using a calculator to evaluate trig functions. To evaluate trig functions, we use the keys on a calculator that are marked sine, cosine, and tangent. Be sure to set the mode to degrees or radians depending on the function that you are evaluating. You may consult the manual on your calculator for specific directions for evaluating trig functions. So there's a couple of things that you got to be aware of when you're calculating a trig function on your calculator. You got to make sure you're in the correct mode. Okay, there's basically 3 modes on your calculator: degrees, radians, and gradients. We don't talk about gradients at all in this course. We talk about degrees and radians. So you have to make sure your calculator is put in the correct mode. And I can't tell you how here to do that because if you got a Casio, that works different from a Texas Instrument. A Texas Instrument works different than a Sharp calculator. So every calculator works slightly differently. So you would have to know how to do that in your own one. If you don't, then you have to come get with me and I'll show you how to do that. You can, if you could do a screenshot of your calculator, I could pretty much tell you on my email how to do it by just looking at the buttons on your calculator. So, but then once you got that done, and then punching them in correctly into your calculator is another big deal. So sometimes some calculators, especially the older ones, you have to put in the input first, the angle first, and then hit the trig function. But if you have a more of a modern, that's one that's been built within the last 10 years, then you have to hit the trig function first and then the angle, which is more friendly, by the way. So this is probably one of the hardest things to teach, but it's one of the easiest things to do. The reason it's hard to teach is because of the different types of calculator students have. And you can't just give a blanket way of doing them all because every calculator works differently. But they're easy to do if you know how to work with your calculator. Okay, so what we're going to do on this example 7 here is we're going to use a calculator to find the value of the 4 trig functions. So if you notice, these 2 angles are radians. You're like, well, wait a minute, the second one's not a radian. Oh, yes, it is. because it's 1.5 radians. You're like, how do I know that? Because there's no degree symbol. So when you punch this into your calculator, you have to hit sine pi, find the pi button, divided by 4. Close your parentheses. Okay? Now, before you do all that, though, you had to make sure your calculator is in radian mode, and that's important. And that's sine of pi over 4 is 0.7071. Now, here's the thing. If you have certain calculators, they will not give you the decimal place automatically for some of the angles, especially if it's an angle that's special like pi over 4 is. If you recall, we took the sine of pi over 4 a while ago in some previous slides back, and sine of pi over 4 was the square root of 2 over 2, if you recall. Right? So sine of pi over 4 is the square root of 2 over 2. But guess what square root of 2 over 2 is as a decimal? It's 0.7071 when you go out to 4 decimal places. So that's what square root of 2 over 2 evaluates to if you change it to a decimal. However, some calculators, when you evaluate sine of pi over 4 on it, it will not go directly to the decimal. It'll give you the square root, it gives you the exact answer, especially some of the Casios. So a lot of the Casios will do that. Texas Instruments, some of those, I've seen those do them as well, but some of the more popular calculators in the TIs, they don't. But some of the Casios do. That being said, I am more of a fan favorite of the TIs than I am of the Casio, just because I'm more familiar with them. It's not because they're better, it's because it's what I'm familiar with. Okay, so don't go out and buy a TI just because I like the TI. If you have a Casio, stick with it. Okay, as long as you can use it correctly, you're fine. Okay, but it's got to be a scientific calculator. Remember, we're not allowing you to use graphing calculators. So don't come in one of the tests with a graphing calculator. You will not get to use it. Now, cosecant of 1.5 radians. Now, I give you the exact answer as 1.0. Well, it's not exact. It's rounded to 1.0025. Now, that cosecant is not on your calculator. Cosecant is not a button on the calculator. You have sine, you have cosine, and you'll have tangent. That's all. So cosecant is not going to be there. You're like, well, how do you get that 1.0025 then? You have to remember something. You have to remember your trig identities. So to do a cosecant, what is cosecant? Oh, it's 1 over sine. So on a calculator, you would have to punch that in. You'd have to hit 1 divided by, hit the sine function, and then most calculators will automatically open up a parentheses for you. And then you punch in 1.5 and close up the parentheses off. So on your screen, what would happen, it will look like that. It'll say 1 divided by sine, and then 1.5 will be enclosed in parentheses. And then you hit enter, and then 1.0025 rounded would be your final answer because we're rounded to 4 decimal places. So, okay. So that is basically the summary of this section, okay? Now, there's a lot that's not here, okay? There's a lot of stuff that was redundant, but it's not the easiest thing to understand for those who have never had trig before. I understand that. But what you guys need to pick off of this video is this. You need to go back and look at all those identities that I've given you. Okay, you got to know those. See, the thing is, you can't do cosecant of 1.5 if you don't know that's 1 over sine. The calculator doesn't help. If you do not know what cosecant is in terms of sine, the calculator won't help you. Because there is no cosecant button. So you have to find out which identities that relates to. Cosecant and sine are reciprocals. That's how you punch it in. So that's the thing you need to do is you got to go back, look at all the slides that I've done before. Sure, write all the previous examples that I did for you, write those down. But the main thing is the basic definition of all 6 trig functions. The sine of t is the y coordinate, the cosine of t is the x coordinate, the tangent of t is the y coordinate divided by the x coordinate. That was the basis, remember, at the very beginning of this video. And then the reciprocal trig functions that followed after that. Okay, and then we start talking about the Pythagorean identities, the quotient identities, the even and odd identities. So all those identities that we have discussed prior to this needs to be put on an index card somewhere and just memorized. You just kind of focus on those. Okay, you can't do anything else if you don't know those. So, but the good news is if you do know those well, the rest of it's really just algebra. It's all it is. So it's basically just calculations. Okay? So, but you got to know those identities before you can move to the next level. All righty? But again, I mean, I know it's confusing. If you ever get to some of these examples, though, in your homework, and you're like, I don't remember covering that so well, send me a video or send me a request, and I'll help you out through that, and I can give you give the class as a whole, not just you, but I'll give the class as a whole a snippet of the answer that you're asking about. So, okay? So if you have anything else, let me know, and I'll see you next time on my next video. You have a good day.